Hey everybody, it's Mitch again, and our project this weekend is to make my bench cookie standoffs fit into my MFT. I can't use that one because it's got stuff on it. So if you don't know what those are, this is a bench cookie from Rockler, and what it is just this piece of plastic with foam on both sides. It doesn't move around. It can screw in these things so you can put them up high if you want, and now I've got a couple different lengths. And the idea is they can fit inside of your dog holes on your workbench. Now, the problem with this is these are 3/4 of an inch, and this is a Festool MFT table, which is 20 millimeters. 20 millimeters and 3/4 of an inch is not the same measurement. They are slightly different. How different? Not by much. Enough to make you crazy. But the problem is, if you want it to be semi-solid, you have to do something because, as you can see, that wiggles just a bit too much. So my solution was to design up this little thing here. I've still got the brim on it. And it is literally, and I kid you not, 0.2 millimeters thick is all it took for me to get that in there. So here's one that's been installed. It is not 100%. That one doesn't fit very well because, let me draw one of these. I haven't finished polishing the end. Like that, and that, and as you can see, it still wiggles a little bit, but not as much as this. That wiggles a whole lot, and that wiggles a little bit. Does it matter to these? Probably not. If I need something solid, I'll use a real bench dog, and that is perfectly better because they're precision machined to fit the hole better. And use that if you don't want things to move. So that would be things for like jigs and other stuff like that. But I still want these to be fairly stable. So I came up with this little thing, and it seems to work just fine, except for the fact that I've got a few little things to kind of tweak out of it. Mostly the fact is, these things are not 3/4 of an inch all the way down the shaft. It is pretty much exactly 0.75 inches at the end, and not exactly 0.75 inches right there. So that means that it is slightly looser on the bottom versus the top. And of course, since we have this piece of plastic, we have to put it in here from this direction, which means that we have to actually take that into account. So we can't make it that size, we have to make it this size. And to be quite honest, you would never know. I mean, you can feel it move a little bit when you squeeze it, but not enough to worry about matter. So I'm working through getting this to final dimension. And again, the way I printed it is I just print it with a brim on the bottom because it has to be stable, because that is not going to stick very well. So we print these off, we put them on, take off the brim, going to polish it up a little bit, and it will fit in. And the reason these tolerances are such a big deal is not every manufacturing process is going to produce the same exact thing, especially in plastic. With metal, it's a different story. Not every hole is going to be the same because of time. Plus, the machine kind of move a little bit, so they're all going to be a little bit different. So here is how I've been dealing with the brim. So just going to put that on there like that. Take a pair of pliers. I'll literally just pull it all off. It should all come off in a circle like that, as you can see. And then I just take a utility knife and I go around it, around the edge, and get it to where I want it. And then generally what I do is I take it off afterwards. I put the end that is had that taken off at the top, because that is going to have the most friction on it. I say that. That goes in fine. Put it all the way on, take it off. I guess there's too much of that. Okay, so there's some residual stuff on the inside. Just take your utility knife and kind of go around. If you have a reamer, that might work. But I'm basically just scraping the edge. Now let's give it a shot. There we go. Like that. And that goes on. Ooh, that may be it right there. Okay. So that's how well it fits. It fits too well. There we go. Okay, I think I finally got to my magic number. Let me get this out. Take a look. So I'm still debating if I want to actually glue these on. I don't think it'll hurt anything. But let me make one final thing there. One final change, and then I'll take a look. Because basically, the reason I say that is I set the diameter of these and they almost will not come off. So it's really kind of what you're after. So let me make one change and do this. I forgot to mention, when I started on this project, I realized I had actually tried this twice before. The first time I used electrical tape wrapped around it, and that didn't work very well at all. And the next thing I did is I took really large shrink wrap, like for electronics, and put on there and shrink wrap it. That worked pretty well, but this is years ago before I even had a 3D printer. So I think this is the best thing. So I want to mention those two other options if you don't have a 3D printer. But since we're doing 3D printer stuff, let's try it. So let's go make that one final change and see if that is the one that did it for us. So yeah, so the first one was 20 millimeters, 20.15, and this one was 20.10. So let me go make one change and I'll be back. Okay, here's how we put this on. So this is just a reamer thing. Just gonna do the inside. Put this on there a little bit, and then take a pair of pliers and take off the brim. Mostly comes off in one piece. Now these are really, really tight, so I'll take it back off this way, and I'm gonna put it on backwards so that the end with the brim is up near the top. And I'm gonna put it on, and this is really tight, so I'm just gonna really put it over the hole to the side and push it all the way down. And it should come out flush. And goes in. That has almost no wiggle at all. So it won't come out very easily. That won't go in at all. Again, that's the problem with some of these. They're not all the same hole. That won't go in. And that one won't go in. So again, this is just trial and error stuff. Okay, so I think I know what happened. So I think I need that deflection. That is interesting. So on that one, where'd the other one go? On this one, well, I think that's fine. So on the one I just did, which is that one won't go in, I made the inside diameter 0.74 inches, which is a little bit small, and that's why it was such a snug fit on this. The outside diameter is still 20.1 millimeters, which is what this is. But that seems to have a better fit. So I wonder if there's a correlation between how tight this is versus this. Maybe it's just a little bit more give. I mean, this is, in all honesty, that's probably perfect the way it is. Yeah, that's not going anywhere. And again, I'm not really, half this is me wiggling the whole table, not just that. But that is fascinating that I made this smaller. Just look. So this comes in at 19.998. This one comes in at 0.98, something or the other. Which is close, because if I look at these, they're in the 0.9 range, but the bottom end of the 0.9. That one's actually less. Whereas this is the top end. No, that one's not. That one's 20 all the way. 19.94. Actually, that's what we want. Yeah. This is the one that doesn't fit. Yeah, this is over right there where it matters. Because again, remember I told you this is thicker at the very edge versus down here. Down here, this is perfectly fine. That's what I was shooting for. But this one's the one that matters. Interesting. Okay, so I'm going to go back to 0.745 as the internal and 20.1 millimeters as the external. So I'm going to print one more of those and verify that works before I reprint everything. Alrighty, so I think this is it. In, pretty solid. Some of the holes are a bit tight, which is expected. That kept my thing. Yeah, I don't know if I want to glue these on or not. I can't make up my mind up. I think the answer is yes. Yeah, I want to glue it in. And probably what I mean, you could use epoxy. Epoxy's kind of thick. I think what we'll have to use is some thick CA glue. Put it in these joints right here, where those little things are. Put that in there. Put the bench cookie on top. And the idea is you put your stuff on to work on it. That's my design for this table upgrade. Another project. So there we go. So that is it. I think I've got 7 more of these to print out. I don't even know what these are. I mean, they all fit, but I don't know how big I made them. So I'll print off 7 more of these. I'll try and get that one off, which may be an issue. Maybe tight. I may have to cut that off. Oh, we can do it. Oh, we can do it. We can do it. We can do it. Oh, there we go. Okay. So, good to go. Okay. So, 0.0745 inches on the internal diameter, 20.10 on the outside diameter. So that's basically, I'm converting from the imperial to the metric on the imperial inside, metric outside. And then when I get into Fusion, I'll explain how I did all that and all the parameters, and then I'll have a link to my model up on MakerWorld, and that should do it. So yeah, so if you need this kind of thing done, then hey, here's a model to do it. If you don't, then there you go. But yeah, I was working on this the other night, and I'm like, has somebody done this? I mean, it seems kind of simple. I mean, seriously, it's just a piece of plastic, which is everything we do with 3D printing. So anyway, but I could not find anything, so this may be the first, and there'll probably be 4 people in the whole world that use it, but if that helps out those 4 people, there we go. And here we are inside of Fusion. So as you can see, this is not a lot to it. Where the magic happens here is with the parameters. So there are only a handful, as you can see. So we have an inside and outside diameter, a depth, which is the length of the piece. I have something called excess, and then I have a base outside diameter. And so here's how I decided to do this. So I know that my inside diameter is going to be 0.0745. And then, again, we talked about this. I changed it.
The depth is 25 millimeters, which is on that specific bench cookie standoff, it basically is the bottom part. And you saw when I slide it on, it fits perfectly. It's 25 millimeters long. You can change it to whatever depth you want. The excess is a parameter that is used to compensate for the shrinkage of the PLA filament. So using ChatGPT, we did a kind of a rough guess of what would happen, and what I came up with is my base outside diameter I know is 20 millimeters. It's going to shrink some. The shrink needs to be taken into account. I started with 0.15. It was too thick. I went to 0.10 millimeters, and that turned out to be perfect on my setup. So again, everything that I do is going to be dependent on my equipment. So my MFT, my bench dog cookies, I don't know when I purchased those. If you go to Rockler and buy bench dogs, or you have another brand, you're going to have to modify this. Now, here's what I'm doing, and I'm going to show this after I publish it up to MakerWorld. But if you didn't know, MakerWorld added a new customization feature. I think you may have seen me do a video, or if you didn't, I did a video on using customization models where you actually have an open SCAD file that you can create your own model. So somebody created this model, and you just go and modify some parameters, and it will generate a new model for you. They added that same capability to read Fusion files. The only caveat is you have to make your parameters that you want people to be able to modify to be favorites. And again, I'll show this here in a little bit after I've uploaded it. So normally what you do is you put your model up there, your Bamboo Studio model. Then if you would like, you can also include the raw files such as Fusion. And so we're going to upload that. And then this new feature is like, oh, you've got parameters. I'm going to make this customizable. And the reason I'm doing this is so that you can tweak it without having Fusion, which is a really cool thing. So these are the different things that I used. And then what I would do is I would just select it. Then, whoops, sorry about that. Select it and then go to File, 3D Print. And then it goes to Bamboo Studio. Click on OK, and it would open up within Bamboo Studio. And then I would change the settings there. So let's jump over to Bamboo real quick, and I'll show you a couple things that I had to take into account. So here is the model as we see it. I'm going to get rid of all these other things here sometime. Most everything was the same. I turned off the prime tower since it was one color. We didn't need it. I also set the brim type to be outer brim 3 millimeters, because having a 0.2 millimeter model is just probably wouldn't work at all. And the only weird one that I had to do is I had to change the wall generator from classic to Arachne. And if I had it set to classic, it would not work. I mean, will it say it here? Huh, interesting. When I first started working with this, it would not, it kept telling me that it was not on the build plate, and never did figure out why. But I changed it to Arachne. I did some research, found a video, said changed it to Arachne, fixed all the problems. I am also using 0.2 millimeter strength, and I'm using a Bamboo A1, of course. So, and I'm using PLA standard. So I'm using Overture products. And I tried, so this is just standard PLA, in some cases PLA Plus, but in this case it's just standard PLA from Overture. PETG does not work. It's too stringy, so that small of a line width, it would just not adhere to itself. Could have been something that I had in my settings, I don't know. But I tried it with PLA, matte PLA, and PETG, and matte PLA did work, but it seemed to not be as strong as regular PLA. So I would advise you to change these to regular PLA to get the best thing. If your mileage varies, I would love to have you put a comment in the MakerWorld model, so that you can share with everybody if you came up with a different way of doing this. So that is pretty much it. So I will put this up on Maker World, and then I'll come back and show you how to actually use it for yourself. Alrighty, so we are back in Maker World. As you can see, my model has been published. It's called Rockler Bench Cookies, Bench Cookie Bushings for Festool MFT. It's hard to squeeze all that in 50 characters, but barely did it. And just a couple of pictures here, and then the important thing is this customize button over here. So click on customize, and it says, oh, it's a Fusion 360 model. I'm going to customize that, and it's going to load up the interface with the parameters. And remember, if I go back over to Fusion, any parameter I set as favorite, which was all of them, is showing up on this screen here. So we have inside diameter, depth, excess, base, inside, outside diameter. Is that the ones we want? Let me verify this. 2, 3, 4, 5. Outside. Yes, okay. Sorry, this is the first time I'm seeing this, so that's why I'm kind of fumbling around it. Since this is a calculation, it didn't put it in here. That's actually pretty interesting. I like that. So only raw data comes through. So since, again, this is a combination of the base and the excess, it's like, okay, you don't need to model that because you're doing it behind the scenes. So what we would do here, like if I wanted to make that 4, and I make this 1, and you could regenerate it. And it's not going to change much because it's a little bitty thing. This is not as fast as the SCAD version is, but it did do it. Interesting. Yeah, sure did. And then basically you just download it. Say it's an A1, whatever printer you have. Click the download button, and you can download either the 3MF or the STL, depending on what you want to do. Then import that directly into Bamboo Studio, and you can print it. So that's the idea of this, is you don't have to have Fusion to make this. Now, I would test it out and make sure that everything is going to work the way you think it's going to work, or just use the stuff that I left in the model. That's pretty much it.